Good day everyone, especially to Ms. Marabismo. Today, we'll be focusing on the research techniques used in this study, the beyond classical sulfone chemistry. So this paper primarily investigates the use of catalytic methods to improve CS band formation in sulfone compounds. These catalytic reactions are fundamental in enhancing the efficiency of chemical processes, particularly in agriculture, where the goal is to develop more effective agrochemicals. So, in this study beyond classical sulfone chemistry, metal and photocatalytic approaches for CS band functionalization of sulfones, these various research analysis techniques were employed, primarily involving the catalyst and spectroscopy. The researcher used a catalytic reaction to analyze the efficiency of sulfone reaction, focusing on nickel and iron catalyzed cross-coupling processes. So additionally, NMR spectroscopy or nuclear magnetic resonance and mass spectrometry were used to determine the structure and purity of the synthesized compounds. The catalytic process were analyzed based on their yields, radioselectivity, and potential agricultural application. So the K reaction were monitored under controlled conditions to evaluate their efficiency, and while it produced agrochemical compounds were tested for biological activity against the pest and fungal pathogens.
Research analysis technique. To analyze the role of VOC, we employed several research techniques. We conducted field studies to collect air samples from various agricultural settings, measuring VOC concentrations using gas chromatography, mass spectrometry, GCMC. This method allows for species identifications and qualifications of different compounds. Additionally, we perform controlled laboratory experiment to evaluate the effect of specific VOC on plant growth and pest behavior, enabling us to draw correlations between VOC emissions and their ecological impact.
Photocatalysis. Another key techniques employed was photocatalysis, where light energy is used to accelerate chemical reactions. Photocatalytic methods were particularly effective in enhancing the efficiency of the sulfone-based reaction. By using light as a catalyst, the study was able to achieve higher reaction rate and yields, producing compounds that are both agricultural beneficial and environmental sustainability.
To analyze the structure and purity of the synthesized compounds, NMR spectroscopy, nuclear magnetic resonance, and mass spectrometry were utilized. NMR spectroscopy help identify the specific bonding pattern in the sulfone derivative, confirming successful CS band formation. Meanwhile, mass spectrometry was used to measure the molecular weight and purity of the products, ensuring they meet the desired chemical specification.
Biological activity testing. Once the sulfone compounds were sanitized, their biological activity was tested against agricultural pests and fungal pathogens. These involved applying the compounds to infected crops and measuring their effectiveness in controlling pests and disease. The findings show that the newly developed agrochemicals were not only more efficient but also had enhanced pest resistance properties, contributing to better crop protection.
In conclusion, the combination of catalytic method, spectroscopy, and biological activity testing provide a comprehensive approach to analyzing sulfone-based compound. These techniques allows the researcher to develop agrochemicals that are more effective and sustainable, providing valuable tools for improving agricultural productivity. Future work will likely focus on refining these techniques to make the process even more efficient for industrial use.